Welcome, Moon and Star. I have prepared another video for you. This time, it is the phylum Antitremata, which is a peculiar one. The basic body plan of these organisms consists of a bilaterally symmetric mantle shielded by a dorsal and a ventral valve, both made of apatite, with a stalk growing out of the back of one of the valves. In the most basal members, living in underground bodies of water and subglacial lakes, the stalk is covered in a tunicine cuticle, and the mantle bears multiple lopophores supported by an arm skeleton, made for filtering food particles out of water. The Shellubim and the Zhor represent unique experiments in adapting these organisms for life on land. Shellubim are sessile as adults, like their aquatic ancestors, and are best described as planimals. The tunicine stalk is hardened into a wood-like stem, with many roots permanently anchoring it into the Martian soil. Extensions of the circulatory system allow these roots to take up water and minerals from the ground while also excreting waste. When Shellubim open their shell, large wing-like organs extend out of the mantle, supported by bony rods, likely evolved from former lopophores. These wings possess tissues of photosynthesizing cells, likely in the form of aerient endosymbionts, which allows the organism to fuel its resting metabolism. In addition to this, one or more lopophores may extend out of the mantle, studded by setae, which are used to filter aeroplankton down to their base, where the mouth lies. Interestingly, these tentacles sometimes possess a single, simple eye at the tip, somewhat similar to what is seen in Trichordata. Apart from these eyes, Shellubim possess statocysts, and possibly also air pressure sensors. These help the organisms detect the approaching of potential predators and weather changes which might lead to dust storms. When such danger approaches, the wings are folded in, the lopophores are retracted, and the shell is firmly shut. In this state, respiration mainly occurs through cica, microscopic canals inside the shell. Shellubim reproduce similarly to plants by shooting gametes into the air and letting those be carried away by the wind until they land inside the lopophores of a potential partner, which redirects them into the cloaca. Does a Shellubim not receive any gametes during breeding season, it can engage in self-fertilization. Usually, the fertilized eggs are incubated inside the body until hatching. The insect-sized hatchlings are quite different from the adults. They are mobile. The stalk is soft and underdeveloped, the lopophores shorter, and the shell is unmineralized, while the wings are more strongly developed and actually used for flight. After hatching, the parent spits the hatchlings out of the cloaca into the air, where they spend most of their juvenile life as aeroplankton. It is likely during this phase that Shellubim acquire their endosymbionts by feeding on phytoarianta and incorporating them into their tissues. When a larva eventually grows too big to fly, it settles down on a suitable spot. The stalk elongates, digs into the ground, and hardens into the vegetative stem, while the shell mineralizes. To facilitate much of this development, the now useless higher nervous system and much of the wing musculature are disintegrated to reallocate the resources. By comparison, the Zhor seems like a more conventional adaptation towards land life. It completely lacks the ancestral stalk, and its ventral shell is shaped into an elongated cone, which holds most of the mantle. On its rims grow two simple exoskeletal tunicine legs, which drag the body forward. The dorsal shell acts both as a lid for the body, when the mantle retracts back into itself as danger approaches, but also as a suspension for the Zhor's feeding organ, which is an extendable bony proboscis with a mandible at the end. It somewhat resembles the mouthparts of a dragonfly nymph. The Zhor is largely herbivorous, feeding mainly on fractarian flora and Shellubim roots, but has on occasion also been seen ambushing smaller animals scuttling by. The Zhor possesses a large gut in its conic shell, used for digesting tough materials. The digestive tract begins at the base of the mouth and winds its way almost to the tip of the shell, before doing a U-turn back towards the front of the body, where it exits as a cloaca right underneath the base of the proboscis. All members of this phylum have such a U-shaped gut with opposing ends, not too dissimilar from what is seen in Earth's phoronids, and this is where the name Antitremata comes from. I hope you enjoyed this video and look forward to the coming ones. Make sure to like and subscribe, visit the project's original website, and maybe also check out my Patreon Yunhua. There you may get to view the next videos early.